No. Yeah? Testing one. Whoa. Okay. Cool. And don't you forget it. You said he's got the power. Okay. We've got lots of those today. Hello, my name's Mark Lenigan, and the title of my talk is Community Wireless Networking. I've been involved in community wireless networking since the late part of September 2001 when I joined the Champaign-Urbana Community Wireless Networking Initiative. And from 2000 and late 2003 to 2004, I was involved with the Detroit Wireless Project in Detroit. No, I'm actually using that, actually. We're going low tech today. Actually, that needs to be turned towards us. Yeah. We still good? We're rolling? Okay, good. So anyway, I should start off by saying what is a community wireless network, because the definition I tend to use is a bit different from what you're typically going to hear. I'll differentiate between a community network and a municipal network. And a community network is one that's a grassroots, usually a nonprofit group. It may have a for-profit element, but I don't know of any of those, honestly. And the purpose of this network is to directly benefit the members of the community that it serves. That if they believe that they need greater internet access to bridge the digital divide, to provide educational services to far-flung regions, like for example, there are Indian tribes in Southern California that use community wireless networking software and routers to link disparate reservations together so that they can maintain their cultural identity and provide the education they want to their children. And it will serve the community's unique networking and communication needs. In contrast, a municipal network usually involves the municipal government and typically gets into the same sorts of problems and pitfalls that cable TV companies and concessions get into, that the municipality will pick one company to design and install and build the network, and then essentially they will gain a natural monopoly on this service and be in exactly the same situation as you are the cable TV companies or ILEC telcos and things like that. And basically, the reason for wanting to start a community network is to get around these things. I first got involved in this because where I lived in Urbana, I called up SBC, which was my ILEC at the time, and I told them I really wanted to get a DSL connection so that I could run my own servers and learn more about networking and that sort of thing. And they said, great, we'll pre-qualify you. Okay. The pre-qual says I'm 11 or 12 feet too far away, which isn't surprising because I was about 300 yards beyond Urbana city limits, and like the next thing over was a freeway, and after that was a cornfield. So I was a little put out, but I could understand. But then that really meant that my only two other options for internet service were dial-up internet, which at that distance I was getting an awesome 300 baud. And because my phone lines were probably installed sometime in the 1930s. And cable internet, which has a very restrictive acceptable use policy. So when I heard that there was this group forming in Urbana to bring connectivity via wireless, I jumped on board and helped as I could. And we'll get into the history of the wireless networking movement, community wireless networking movement. Usually they'll start up in the same sorts of situations as the old free nets, if anybody's familiar with them. I mean, Cleveland did have one for some years. Detroit had one. I know there were other communities around that had that. And they tend to want to provide the same sorts of benefits, that when you have local people getting together, you enhance the they're talking about issues that are important to the community. Or you can even just use it as a social organizational tool that, hey, let's everybody meet at this restaurant at this time. And the initial efforts were slow and random because individual people were just saying, hey, I've got this access point or this computer with a wireless connection, I could share it with my neighbors, or there's this other guy that's 11 feet too far away to get DSL, we can set up a point-to-point to him. And there really wasn't too much thought of how far you could go with this. But starting in about late 2000, maybe early 2001, several different efforts got started in various cities that were looking at wider issues of how far you could push this technology. Probably the most famous is Seattle Wireless, which you can find at seattlewireless.net. And they started with long-range point-to-point links across Puget Sound, access points set up in the neighborhoods, and a very, very ambitious and, in my opinion, overly thought-out network topology that they had like 4 different types of routers based on capability and that sort of thing. Also, there was Austin Wireless, which was a hotspot type of all they were doing was setting up hotspots because that's what they decided they needed, was more public places where people could access the internet. And NYC Wireless, who mainly deals in providing wireless internet access to low-income apartment buildings, as far as I can tell. They also work in hotspots, but from the people I've talked to at NYC Wireless, that's what they were working on. And then there was CU Wireless, which looked at how can we build a box that, a router really, that someone with very little technical knowledge could install this on the roof of their home, power it up, and it just works and connects to the internet. The basic system for the CU Wireless router is you've got, if this is your house, you want to have the router as close to the roof line as possible and it'll be mounted up there. It's got an 8 dBi antenna, and then from the side of the router, you'll have a weatherproof Ethernet cable that goes down into the house, and that's the DMARC right there. And from there, they can attach what they want, whether it's another wireless router, an access point. Thank you. Thank you. And, et cetera. And so, so basically, it allows, and what this allows you to do is that as the let's see here. As you said, if these are the coverage areas and this is the city here, as you set up nodes with various coverage that overlaps, and if some of those are connected out to the internet, you gradually, with these self-organizing nodes, because when they power up, they compute their own IP address off of their Mac from a CD image of NetBSD on compact flash. I'm sorry, it's an image of NetBSD on compact flash. And then they compute their own IP address and immediately go into a search mode to see if there are other routers within their range. And if they find them, then they build a routing table from that using the hazy-sided link state algorithm, which was originally developed for the military for highly dynamic network topologies, like when you have things like Humvees and Apaches constantly on the move. So then basically what this allows people to do is just set this up, and as far as they're concerned, it just works. However, that's not really where we started. We first started, made a lot of mistakes. The first system that we started playing around with were Orinoco cards and the infamous or famous, depending on how you look at it, Pringles can antennas. They don't stand up too well to an Illinois thunderstorm. There's a picture on an NCSA website, which I couldn't find before the talk, unfortunately, of one that looks like it had been hit by a truck. But all that had happened was it was rained on. And we also initially started with scrounging PCs, which incidentally was what you saw me working on in the knock earlier in the weekend, and with the similar results that turns out PC hardware is not really what you want to build a router on. It's very unreliable, but it's cheap and readily available. The other thing you can use are things like the WRT54G with custom software, but again, they're only marginally more reliable than PC class hardware. And from my experiences of installing stuff like this in plenum spaces that's not ruggedized, they tend to have a lifespan of about 8 months to 12 months before you have to replace it. What you really want are things like the Socris 4521 or similar ruggedized routers that you can put in, that ruggedized waterproof enclosures are made for, and they'll stand up to anything. The unfortunate thing is because they're so well made and usually made in small lots, they tend to cost several $100s each, which means that you're going to be able to deploy only a few routers per, fewer routers per the amount of money that you're going to have. Usually, to start out with, the best way to start out if you're going to build a network is to pick a region of town where you have, that it's geographically compact, that you can cover it with maybe 4, maybe 12 routers, that they can all talk to one another, similar to this. And then you want 1 or 2 connections to the internet. This will, and once you get this going and can prove that you know what you're doing, then you can go out and pushing companies in the area, or perhaps agencies that will grant you money, that sort of thing, and start seeking more funding, because once they're relatively unwilling to trust just anyone, but if you demonstrate just even a little bit of clue, then there's many, many more people who are willing to help out. You'll find that people will be willing to, people in the community will be willing to donate all sorts of things, even up to servers, co-location space, sometimes office space, money so that you can file 5013C paperwork, all that good stuff. And so with that covered, why would you want to do community wireless? The usual reason initially is underserved communities, which doesn't necessarily mean low-income communities. In Michigan, where I live, there are middle-class communities that residential, or what am I thinking of? Subdivisions here that clearly would be in the target market of DSL, but for some reason the telcos aren't there, and in some cases the cable companies aren't there either. But they're a market for the internet, and this is that when the FCC does its survey of where broadband is available in the US, they do it by zip code. And if only a portion of that zip code, if one household in that zip code has access to cable or DSL broadband, according to their database, that area is served. And it doesn't matter that if, across town, across a major road, the other side of the tracks, there's no coverage. Oh well, there's some coverage, and therefore that counts enough for the FCC. And why I'm so up on DSL is that typically you can get DSL with fewer restrictions to run servers, to be an active participant in the internet, rather than the way the cable companies typically want you to use their residential connections, which is that it's just a big pipe. You can download stuff. They don't want to see you run servers. They don't want the problems of, the potential security problems you're going to cause because you're actually using your connection. And why I call them typically community wireless networks rather than free is that ultimately, if you're getting out to the regular internet, someone owns the connections, the lines that information travels over, Sprint, Quest, et cetera, and they're all toll roads. So if you're providing free access, somebody is paying for it, which is why you need to approach, if you want to provide free access to the internet, you're going to need to approach some kind of sponsor to pay for those costs. In the Detroit project, what we had worked out was there was actually, Quest was running a promotion on their business T1s that existing T1 customers could get a second T1 for free. And the customers were initially saying, well, why do we only need one T1, why do we want to get a second one? And so basically Quest, the regional Quest technical sales officer and one of our representatives would mutually approach businesses and say, well, if you get the second T1 and donate the bandwidth to the wireless project, we're 501(c), and you can take it off on your taxes. And instantly, it's a win-win situation for everyone because the business gets the recognition of supporting a community program, they get money off in their taxes, Quest sells more, which they like, and we get bandwidth for what we want to do. And those are typically the kind of agreements that you need to be flexible enough and willing to work out in order to get what you want done. In the Champaign-Urbana project, particularly in the beginning, we used to joke that our motto was, we have no budget, because at each meeting on Sunday afternoons, we would typically have 2 or 3 new people show up and be interested in the project, and they would be just bubbling over with all kinds of new ideas. And we would say, you know, honestly, we really like your ideas. These are really good ideas. And we would love to, you know, at least take at least some of them and implement them, but we have no budget. We're running this network on old PCs, on routers that we can buy with our own paychecks, and free software, and basically spit and bubble gum. So, you know, you, like a lot of projects, you learn to just scrounge and do with what you can. And as far as the actually the model I like to call it is that you're essentially running your network like maybe PBS or NPR, although you know that you have sponsorship at the beginning of a session, if they, you know, with a splash page or that sort of thing. Typically, people are willing to put up with that, or if you're getting a direct grant from somebody, rather than like some of the commercial wireless operators that want to constantly put some kind of flashing ad window up there, or like the old Net Zero or that sort of thing. As far as topologies of the network, there's this, the mesh topology that I talked about earlier, or you can also, depending on your, this works in very well typically in very flat terrain like Champaign-Urbana. It works less well, and the thing about terrain is it's not just the physical geography, it's also whatever artificial geography is there. Like if you're in a city with lots of buildings, they count as mountains and canyons as far as 2.4 gigahertz is concerned. So, and you can, if you can get access to the roof, you can use that to your advantage. If you want to do single point to multi-point network, which is typically, if you've got a very tall building, single omnidirectional antenna here with a coverage area, something like that, and then you can have multiple hosts with directional antennas pointing at it. Now, this is easy to implement, or easier to implement than it has the problem of if you have a hardware failure here, the whole network goes down. So, I mean, I tend to like the, now granted it's what I worked on, but I tend to like the Champaign-Urbana model of router on the roof and then another access point inside, because it gets you around interference issues and the problem that most buildings are opaque to the wavelengths you're going to be using. As far as if you wanted to start your own project, which is probably the third part of the abstract I talked about, you need to first look at the what I would call the social or perhaps the political organization of your group. In Champaign-Urbana, which is still a very successful community wireless initiative, we started out as a conscious effort in anarcho-syndicalism, which we boiled down to one simple rule. First of all, everyone is welcome at the meetings, but if you suggest something, congratulations, you just volunteered to do it. If you think we need a website, congratulations, you're the webmaster on it. If you think our current website, guess what? You can redesign it. This turns out to be a very, very effective tool for managing people in the sense that, first of all, you have the iterative nature of volunteers who are enthusiastic about working on something, and second of all, it neatly solves the problem of the critics who are unwilling to actually contribute to your project, which is actually a problem that I've noticed in volunteer efforts, that you'll tend to get not just enthusiastic volunteers, but somebody who is convinced you're doing it wrong. But yet, when they tell you you're doing it wrong, they want you to just do what they say rather than, okay, just throw away all these things that you've already worked on, all this money that you've already spent, and do it my way. And when you say, okay, why don't you do all of that? You raise the money, you build the routers, and maybe your network is better. We'll see who wins. However, eventually, you are going to, much like Jason Scott said in his Wikipedia talk, eventually politics and the law and finance and all of these real-world concerns catch up to you. So you're eventually going to be needing to file 501(c) paperwork. You're going to be needing to establish yourself probably as a state corporation. You're going to be needing to budget your money, keep track of your accounts. If there's any taxes that you have to pay, you'll also be needing to get some kind of liability insurance, because if you have a hack space that you're working on this stuff, usually if you're renting, they're going to require that. And also, you're working on roofs. You're going to be, whoever your volunteers are exposed to the possibility of injury. And even if you have, obviously you're going to have safety harnesses and all like that, but if the worst happens, something like that can wipe out your organization without liability insurance. And unfortunately, it's not cheap. Getting down to the individual makeup of your group, the kinds of people you would ideally want to have. First of all, you take who you can get. Whoever shows up, that's your group. Hopefully they do work. If they don't, like I said, use the anarcho-syndicalism model, and eventually the people who don't want to work will stop showing up. It actually works great. You're going to want at least one person who knows systems and network administration for servers, who can manage a server, like for email and web servers, that sort of thing. And someone with web designer skills or website administration skills, that could probably be the same person if they're multi-talented. You'll want one radio, antenna, or physics guru. That was my job in the CU Wireless project and the Detroit project. The person who can soothe people and tell them that, yes, in fact, your antennas are not going to give them cancer. That can figure out do site surveys and figure out the best ways to install your equipment and things like that. You're going to want a team, probably 5 or 6 or so, of people who are generally just interested in installing stuff, who are willing to show up on a Saturday or Sunday afternoon and put the router on the roof, bolt it down, run the cable, that sort of thing. And you're going to want one person. This is very important. These people are worth their weight in gold or whatever else you'd like to give them. One person who is the paperwork geek. In CU Wireless, this was Sasha Meinrath, and we all loved him for this because he was the one that was willing to do all of the work that we weren't. He was perhaps not as interested in the computer side of things as he was the social side of things, and I would really credit him with making CU Wireless, or now it's called Kuwin, as successful as it is, because he was able to do all of the work of interfacing us with the rest of the world so that we weren't just a bunch of scruffy hackers. And if you're developing your own software, obviously you'll need people who have the skills for coding and that sort of thing. However, there are a number of software packages out there. There's the CU Wireless Station Boot software. There's Pebble Linux from NYC Wireless. Pyramid. There's even, although I don't really like it, I mean, if you're doing just the access point thing, you could try public IP. It works for some people, but not others. And a whole host of others that keep cropping up. As far as leadership and organizing the club, guess what? If you started it, you're the guy who's the leader. Whether you like it or not, people are going to look to you as the person who's in charge. Eventually, when you get 501(c) status, you're going to need a board of directors by law. They're going to be, and you really want to make sure this is an elected body and that there's clear rules for electing members when a member leaves, because you don't want to get into the problem that, for example, the Detroit Freenet did, which is where the whole board of directors more or less got burned out at once and all resigned except for 2 of them. And then, according to their own bylaws, they didn't have quorum. So they legally couldn't do anything. And that's basically what caused the group to go defunct, is that they couldn't manage their budget. They couldn't make any legal decisions about what to do with their resources. So you want to make sure that if somebody leaves from the board or decides to take a leave of absence or whatever, you fill that spot just in case other people decide to leave. Also, make sure that the board doesn't devolve into a social club. It might be, if you have to pick a place to meet that's public, it might be better to pick a coffee house than a place that serves alcohol. This was a problem with the Detroit project. And it tends to be a problem if you're just meeting to get something done. I mean, everybody likes to meet over pizza and beer, but if you keep doing it all the time, eventually it's more about that and less about building the network. As far as the hardware and software needs of your group, and I'm speaking now about for organizational purposes, it's imperative to have your own server that's co-located someplace so that you have, your website served off of that server, email served off of that server, whatever you're doing, so that you're in control of that. Again, the Detroit group decided to try and do all of this using free services on the web, because you can get, email lists that are served freely on the internet, and web forums that are free on the internet, and comment services like HaloScan and all that are free. But trying to cobble all this together winds up making you look, number one, like you don't know what you're doing. And if you're doing that, you probably don't. And number 2, it's brittle and will inevitably fail and wipe out the information that you're trying to store there. So your own server that you can back up, and maybe it's perhaps it's a no-brainer to this group, but that's vital, because that's literally the lifeblood and the core of the group, is your ability to communicate with one another anytime somebody has a good idea. And on the website, just for to show that you're active, you want a node map that you update every time you put a new node up. Every time you do something, you want to show that there's something happening, and that there's always something that that you definitely are an active group, and one that people should want to join and get involved with at some level, whether it's they want to have a node on their house, or they want to join and help build nodes or install them, or help educate people about the benefits of this and that sort of thing. There's all kinds of roles that any volunteer can play. And of course, whenever possible, free and open source software is the way to go, because we have no budget. And usually, I've found if you just put it out there that you need, whatever you need, people will donate. We've had quad proc compact servers with RAID and gigs of RAM donated to us for free. and the space and bandwidth to co-locate them. Usually, because let's face it, if you're even a modest-sized colo, the bandwidth that such a site's going to take up is going to be lost in the noise on their MRTG. And also they get the benefit of saying that they support this local group, because it's really cool to be involved with one of these things. Everyone wants to be involved with this. That's what's neat about it, is you wind up having tons of allies. And as far as hardware, remember to back stuff up because it's donated and it's old. And I yeah, been there, done that, or rather not done that and paid for it. It's also crucial to have a space to meet where you can keep all of your gear, keep all of the esoteric tools, the coax crimpers, antennae, built nodes, whatever. Trust me, you're going to get more stuff than you ever thought you would. Just, even stuff that's just donated to you. PCs, if you say, hey, we need to outfit the office, people will all of a sudden say, we've got all these old couches, we've got a coffee maker, a microwave oven, and you'll have like 5 of them. That too. So you really want a space that you can use as a workshop. Now, granted, a lot of people who are big into nonprofits, they're going to say, we want the office downtown. We want, there's this quaint old high-rise in the historical part of town, and it would be great. Well, yeah, except for the fact that it's, and I'm speaking from experience here, except for the fact that it's a nationally historically registered building, which means you can't run Cat 5. And, oh, you want to use wireless? That's a good idea, except that it's made out of stone. So, and, being on the 5th floor of the back side, because that's really where the cheap offices are, is where you're looking across to another building that's on the other side of the alley, you're not really accessible to the public. Nobody can know that you're there. It's kind of imposing to walk up to this granite monolith and, walk in like you're, Neo in the Matrix or whatever. And what you really want is a space that's maybe 1-2 stories tall in a light industrial or on the edges of a residential area, and ideally the residential area that you're working in, so you don't have far to lug all this stuff. And you want it to be friendly. You want it to be a place where people feel like it's cool to hang out. But at the same time, you need to be mindful of your own physical security, the security of your space, and the security of your systems and hardware, because it's, kind of like this place, most people are honest, but stuff unfortunately walks off. As far as, and big plus, big win, 24-hour access if you can get it. As far as selecting the site of your prototype network, you want to pick an area that serves the local neighborhood. Like I said, something along the lines of Main Street in a small town, or a section of town that functions like its own small town with a residential area behind it, because then you can have your hotspots in something like a neighborhood cafe or a bar or a restaurant where you can put your sticker on the window and have public visibility, which is crucial so that people know that you're in the area. And then also be providing access through rooftop routers beyond that. And basically it's very easy to get a hotspot into a place with a lot of foot traffic like a cafe. Because if you break down the numbers for them about how much the hardware costs and how much DSL per month costs, and do that on a per day basis, as Simpson Garfinkel pointed out in like 2002 or so, back then when DSL was much more expensive and hardware was much more expensive, a cafe would only have to sell 1 more coffee a day in order to pay for the connection. If they sold 2, they were making a profit off of their wireless node. Turns out they tend to sell more like 10 more. So when you start putting it in numbers like that a business person can understand, it's very easy to convince them to get 6 megs of DSL in, and then put it a hotspot and put on a rooftop node, and then that can start serving the neighborhood in its immediate vicinity as one of the trunk nodes that leaf nodes that don't have internet access themselves can connect to. And like I had said with the T1 argument, like with Quest and like that, be flexible to whatever, be willing to work with whatever you have available. If you can even if it seems a little bit weird, if you can swing a deal where you can get a win-win situation with various parties in the community, be willing to do that even if it doesn't fit what you consider your nominal business model to be, at least in the beginning. Because once you've proven you know what you're doing, support from the community will be strong to overwhelming, seriously. And you'll find it much easier to actually get money from donors. And what I mean by this is, like just as an example, the Open Society Institute, which I believe is run by George Soros, donated something on the order, or granted something on the order of several $100,000 to Champaign-Urbana Wireless for them to develop their software. So, you know, if you can show that, and the network that they saw was 6 SOCRIS boxes and 8 DBI antennae mounted on people's houses. And so basically you want to build your network as you're able. As far as meetings, I really like the idea, it seems to work well, to have, if you can swing it, a weekly meeting that's about 3 to 4 hours long. Now granted, you don't expect the same people to show up every week. You want your group to be big enough that if only 4 people can get together, then you'll keep maintaining the momentum that way, and you spread out the work to a broader group of people, which means it's less likely that any one person will burn out. Okay, and you want to maintain, I'll skip some stuff here. As far as maintaining the momentum, like I just said, make sure that no one person is shouldering the burden, because if they're the core of your group and they burn out, it just goes away. Make sure that you have enough members that, okay, I said that. And you want to decentralize and delegate as much as possible. Okay, let's see here. That's pretty much, I think I'll end it there and then take questions if anyone has them. Yes?
What do you think of the Meraki box?
I'm sorry, could you?
You know the Meraki project? They're like really cheap access point, and then it's like runs some version of Bluetooth, but it's like actually $60.
I actually haven't heard that. Is this somewhat similar to the phone or Finero network? Okay.
No, it's a small box, I mean, but it's incredibly inexpensive. Early when it came out, a little bit about what I know about the Meraki is it's a small, inexpensive box. I think it runs about $60. When it first came out, maybe 3-4 years ago, I guess. I mean, someone correct me. I think the limitation was how much bandwidth, how much throughput for data, but I think they might have gone over it. But just a few months ago, I think the QWinware, the software that they developed in Urbana, they were able to port to it, so it should really open up some things a little bit. But that's a good question because I was going to ask Michael the same.
Mark.
Mark, sorry.
Okay, yeah. Well, in general, I personally prefer hardware that you're integrating yourself, like the SOCRIS, because it's more likely that sort of thing will stick around longer as embedded hardware than any particular. Now, granted, there's. I mean, I haven't heard the Meraki, but I know that there's Flickinger's company, Mepis, that's made a commitment to making hardware for projects like this. So the hardware is becoming more and more available, but in both of the groups I worked with, we've been burned by finding a really cool piece of hardware that did what we thought, exactly what we wanted, and then finding out that it was end of life, end of service, we can't get support, we don't know, you know, and now we've decided that this is going to be a major part of our network, and it's going to fail in a year or 4 years or whatever, because eventually everything, these things are existing in a harsh environment typically. So I tend to like to keep everything as open as possible, because then I'm in control rather than the hardware manufacturer. Any other questions?
You are not responsible to hand it to the next person. Remember to talk close to the mic. In the light of municipal wireless, for example, in Michigan, the Oakland County Wireless Project, which is a mostly privately backed venture, where do you see community wireless integrating with that, or in addition to that? How do you see those two coexisting, or can they coexist?
I personally think they can coexist because even, well, first of all, Oakland Wireless is an initiative that was conceived by L. Brooks Patterson, the county executive of Oakland County in Michigan, where Stormgren and I both happen to live. And what he wanted was, he wants a wireless network, actually, I think the term he used was hotspot, which I hope he doesn't mean this, covering the entire 900 square mile county. Now keep in mind, a lot of this area is woodland. So I'm not sure how much the woodland creatures are needing email. Basically, what I see happening is that community wireless tends to go where it's needed. There's a natural affinity between independent coffee shops, independent businesses and ventures like that want to draw people in because it's a draw to have free internet in your business as opposed to, say, Starbucks where you've got to pay, what is it, $3, $10 for a T-Mobile ID for the day. So people will naturally gravitate to where they can get more for less. And so there's an affinity between the community network and independent business. And in the sense that as long as the spectrum is not congested, I think multiple networks can coexist. And in fact, like for example, in New York City, there's a number of different wireless and community wireless ventures that are all coexisting in the same spectrum. So I really don't see competition necessarily between them. I think there was another question.
A major problem on any kind of service network is copyright violations, and I don't want to get into a discussion of whether that's right or wrong, but what ISPs and large carriers have is what's called common carrier status, which protects them from liability. So you get a DMCA violation on your network, then all you have to do is put a stop to it and comply with whatever the requests are. You're not going to get sued. Do these smaller projects, do they qualify for common carrier status, or is that never come?
It's never come up on either of the projects I worked for. I would honestly have to look into what the particulars of that are. But this would be another. I mean, this would actually be another example of the legality that I was talking about. That always follows you everywhere. You know that it's another. No matter what you do, no matter how grassroots and independent you want to be, all these regulations creep into what you're doing to make it work. Yes.
Yeah, you said you weren't particularly fond of the WRT stuff. What was the major shortcomings that you found with it? Was it weather related or just flimsy units or what?
Well, it's reliability really. That Linksys, the Linksys WRT series is really designed to work in an office environment. And when you're installing a hotspot, you're typically installing it in drop ceiling plenum spaces, kind of like this one, or places that tend to have poor air circulation, are dusty, are in general hard on electronic devices that weren't designed to live in that sort of environment. So over time, a WRT that might last years sitting on your desk will last on the order of months in that space because it'll wind up overheating or suffering from any other number of failures just because you're putting it in a space that it was never designed to operate in.
So you feel if that could be addressed in, say, repackaging with filters and fans, the unit could be serviceable?
It's a possibility. It's not something I've actually looked into. It's just a personal thing with me. I seem to be death on WRTs, and the last I've gone through 2. So who knows?
You mentioned the different of the hardware becoming so different, the more containerized and rugged hardware becoming cheaper. Is it now to the point where like an impoverished area, getting like the Goodwill computer and a network card is not really saving any money over a more containerized solution. Is that point reached?
Well, you're going to save money if you use the PC class stuff. What you're not going to save is your own sanity, because it's going to be failing at a rapid rate. But the fact that a lot of this hardware is dropping in cost is making it more and more feasible to roll out networks. How are we doing on time? Are there any other questions?